Hello. Today we will be talking about how to use the Agilent 33220A function generator found at your lab station to generate different types of waveforms to display on your oscilloscope. By the end of this video tutorial, you will be able to generate many different waveforms of varying amplitudes and frequencies. First, push the button on the lower left-hand corner of the function generator to turn it on. This function generator uses a series of buttons, knob, and context-dependent soft keys to change signal parameters. There are also two BNC ports on the lower right-hand corner of the device labeled sync and output. Over here at the top, we have an LCD display which we can use to view our waveform settings. Before we do anything else, it is very important to ensure that our function generator is in high impedance or high Z mode. We will discuss why this is necessary in another video, but suffice to say, it is to ensure that the function displayed on this panel is the same as the function you are sending to your oscilloscope. We can change our output impedance to high Z via the following procedure. First, we press Utility. Then, we press the soft key labeled Output Setup, and then we press this button until the word high Z is highlighted. In order to save our changes, we then press Done, and we return back to the main menu. Let's start by generating a simple sine wave with a DC offset. We will seek to output a sine wave with a frequency of 1 kHz, a peak-to-peak voltage of 5 volts, and a DC offset of positive 2.5 volts. In other words, a period of 1 millisecond with a high level of 5 volts and a low level of 0 volts. We select the sine button from the row of wave types over here. Note that they all have markings on the button identifying their shape, and were you to press another button, it lights up and the graphic on the LCD screen changes to represent the shape of the function you have selected. Let's press the sine button. After this, we can use the keypad, knob, or context-dependent soft keys to edit the parameters of the sine wave. First, let's select the frequency of our desired output waveform. We can either modify the frequency of the wave using the knob on the right-hand side of the menu, like so. Note how the highlighted digit over here is changing as I rotate the knob right and left. Or, in order to make larger changes, we can key in what we desire as our output frequency onto the numerical pad. I am now going to press the digit 1, which brings up this menu. Our context-dependent soft keys now indicate the suffix of our frequency, be it from microhertz all the way to megahertz. Note that this particular function generator has a maximum frequency of 20 megahertz. Let's press the key labeled kilohertz. We now see that we have a sine function of 1 kilohertz frequency, otherwise known as 1 millisecond period. Once we are done with that, we can move on to setting the amplitude of our output signal. Let's press the amplitude button. Just like setting the frequency, we can set our desired amplitude of 5 volts peak to peak using either the scroll wheel with the directional left and right buttons to select the most significant digit that we are editing, or simply keying in the value onto the keypad. You see, once I've entered the digit 5, options pop up on the context-dependent soft keys for volts peak to peak and volts root mean square. Let's select volts peak to peak. Note that if we press the button once again, we go to the high level mode. Since we have no offset right now, the high level of our signal will be 2.5 volts, and the low level of our signal will be displayed as negative 2.5 volts. Let's return back to the amplitude. Once we are done setting the amplitude, we can now set any DC offset. For demonstration purposes, I will now set a positive 2.5 volt DC offset. I do that by pressing the button labeled Offset, ensuring that Offset is highlighted, and now I can change the value of the DC offset by rotating the knob Note that I can also set a negative offset by rotating to the left, or by keying in a negative offset by pressing the sign button and then some value. Let's try to set a positive 2.5 volt DC offset. You key in 2.5 on the keypad and select the appropriate option for volts DC. We have now successfully configured our first waveform using the function generator with a frequency of 1 kHz, an amplitude of 5 volts peak to peak, and a DC offset of positive 2.5 volts. As before, we can see the low level of our signal with this offset is 0 volts, and the high level of our signal is 5 volts, which makes sense given our volts peak to peak and our DC offset. We are now ready to display our signal on the oscilloscope. But before we can do so, we have to connect the output of our function generator to the input of our oscilloscope. We can do this by using the BNC to BNC cable. We have already connected one end of the cable to the input channel of the oscilloscope. We have to connect the other end of the cable to the output port of the function generator. This is where you will connect your cable if you are wishing to output a function to an oscilloscope or some other device. The cable in question looks like this and has a bayonet attachment at the end. This goes onto the port, which has 2 pins on either side that serve as guides. In order to attach the BNC to BNC cable to the output port, we line up the channel on each side of the cable to the pins on the output port, push in, and rotate clockwise until it is locked. Make sure to use sufficient force to have a good connection, but not so much force that you break equipment. We are now able to output our signal to the oscilloscope. We can do that by pressing the output key. As we can see, the parameters of the signal on our oscilloscope, namely a peak-to-peak voltage of 5 volts, a period of 1 millisecond, which corresponds to a frequency of 1 kHz, and a DC offset of positive 2.5 volts, agrees with what we have set as our waveform parameters in our function generator. As an aside, if we were to press the graph button on the function generator, the display on the LCD screen is replaced by a graphical characterization of our output waveform. Here we can see the frequency set of 1 kHz, the amplitude of 5 volts peak to peak, and a DC offset of 2.5 volts DC, which agrees with the DC offset as indicated on the oscilloscope. If we were to press the amplitude soft key twice, we enter the high level mode, where we can see that our signal has a high level of 5 volts, which agrees with the oscilloscope, and if we were to press the low level soft key, has a low level of 0 volts, which agrees once again with our oscilloscope and of course our own common sense. This may not be necessary for your labs at first, but could come in handy in the future.